getting different price paths. There you go. So now that we have our simulation results, what do we want to do next? We will define yet another function. And this time we will call it, as part of the Monte Carlo algorithm, we'll call it part 2. Here we will put the input as our simulations df, which we just generated. I will use the prediction period parameter as well. And I will pass the confidence interval. Now, what do we want to do here? We want to create an array of size 10,000, which containing the index values by subsetting indices corresponding to returns and prices respectively. So if we see our data frame of simulation results, we have one column which is generating the price series for the prediction period and correspondingly the return series for that trial. And likewise, for every single trial, we have first a price series and followed by its corresponding return series. So we want to extract them separately as an entire data frame of simulation results for prices and for returns separately. So we will capture them in 2 different arrays. So we will say index return. We will use an NP range. And we will say starting from 1. Why starting from 1? Because the returns start from column 1. And the length of this will be simulations df dot shape 1, which will be the entire column length of the data frame and with steps of 2. So what I'm trying to do here, I want to capture the entire return series starting from column number 1 all the way till the end, and I want to take a hop of 2 because returns are appearing every alternate column, just like prices are. So we will take steps of 2. And similarly, and this is going to capture all the index values which are corresponding to the returns. Similarly, I will capture all the index values which are corresponding to the prices, which will be same as above except for one change. And that change is that it starts from column number 0. So now that we have extracted our indices, we will now create a data frame of simulated prices and returns for the predicted period over 10,000 clients. And we will do that by subsetting our simulation data frame. And here we want to capture all the rows here, but only the index values corresponding to the prices, which we captured in index price variable above. Similarly, a returns df. and index return indices. Okay, let's call our function up to this point and see how we're doing. HDF tail. Just keep it price tail. And I will also print returns TF. So let me call our Monte Carlo function and see what we get. Okay, so it's working fine. So we see now we've been able to segregate our price and return series. So we can continue. Next step is we will compute the CI, which is our confidence interval, percentile score from the last row, which is the end of prediction period, across all columns representing trials. So what we are trying to do is, if we once again look at our price series here, we have 10,000 trials here. And this is the price series for each and every trial over 10 days of price path, which is a 10 days of prediction period. We want to go to the last row. We are predicting over these 10 days. In the last row, which is representing the 10th day of the prediction period across all the 10,000 trials, we want to compute the interval, the range, which represents our 84% confidence interval. So we will compute the prices at 84% confidence interval, or the 84th percentile score, which will represent that 84% of the prices across these 10,000 trials occurred below that price level. Similarly, on the lower side, we'll compute a price level which represents that 84% of the prices across the 10,000 trial on the last day of the trial occurred above that level. So for that, we have a very simple option. First, let's just define a variable. I will call it PR price up range. I will say we have a library called stats dot I must import this library first. So I will import it here. The scientific library called SciPy. Within that, there is a function called stats. So I will import that function. And that allows me to compute the percentile score. So I will do score. Within stats function, I'll do score at percentile. I will pass my series, which is the price DF series. And I'll define the location, which is the prediction period -1, because I want to take the 9th row. And I'm defining the confidence interval. So this will give me the 84th percentile of the price level across all the 10,000 trials on the last day of the prediction period. Similarly, I will compute the lower end. We'll call it low, price lower range. Which will just be the converse of this. This will become 100 minus CI or the 16th percentile. Now I will do the same for returns. Within the defined CI. So I will set up two variables, returns up range. And I will just copy this. The series I will pass here will be the return series. And this will be the lower range of the returns. Then let's just compute this. So prices will remain below percent returns above current price, current spot price. So we are saying what is the upper end of the price and what is the return that represents above the current spot price. And I will just close it out. Okay. Similarly, I will say the prices will remain above, which is the lower range, which will be price low range and returns low range. And this is prices will remain these returns will be representing the return below the current spot price. Okay, and we are saying that our prices within these above range represent particular percent confidence interval, which is a CI, and we want our function to return this whole price series the returns series, the PR upper range, and the lower range. Okay. So we have wrapped up quite a lot of here. Now let's try to call our function, and we will capture the output of this function in all of these variables, which the function will return. So let's say our price series, our return series, our upper range of price and our upper range and our lower range of price should come from this function, which is Monte Carlo 2. When I pass the simulations data frame along with the prediction period and the confidence interval. And let's see. So it's saying that within 84% confidence interval, our price is going to remain between 18,656 and 19,417. So the upper end of the price, the upper range here represents that it's 84% confidence interval. So there is a possibility of error of 16% on the upper side. And similarly, the lower range represents 84% confidence interval, which means that there's a possibility of 16%. There is a probability of 16% of erring on the lower side and likewise on the upper side. So we are getting an 84% confidence interval on the upper end and the lower end of the range. All right. Now we also want to visualize all our triumphs, which we bought in simulations data frame. So for that, okay, let me delete this. We will create yet another function. Let's save our work so far. This will be Monte Carlo 3, let's say part 3, where we will use the output series price, the upper range of the price, up range, lower range, which become our input parameters. We will use the prediction period. We will use the confidence interval and the last price. Last price before we began the simulation, which is the current spot price. Okay, so I'll define a figure here as PLD figure. I'll specify the size. Let's say I do 14.5, which I usually do. Then I'll say we need some subplots. 1, 2, 1. PLT dot plot. First, we want to plot the price series. So, like I said earlier, and just making a note of it. So 0 on our day scale will represent day 1 of focus period. That's because in Python, the indexes begin from 0. So 0 here will be the day 1 of our forecast period. Okay. Let's give it a nice title. Call it Monte Carlo simulations of prices for the next days. Which is our prediction period. All right. We'll draw a horizontal line which would represent our, let's say, y equal to, we want to show in all of these simulations, we want to know where was our last price or the starting price. We will define the various parameters. Let's say we want to represent it by color yellow. Line style equal to, let's say, dash dash. Equal to 4. And we'll call it our current price before we begin the simulation. Okay. And we want to also plot our upper and lower ranges. So we will say here y should be equal to the upper range of price. And we want to change the color. I'll make it green. And the label should be the upper range. At CI confidence interval after a prediction period number of days or the forecast period number of days. And here I will pass CI prediction period. And now similarly, I need the lower range. Which should again be green, but this should represent the lower range. Okay. Let's go on further. And I will do another subplot. The second part. And this time I want to plot a histogram of my prices. So I will pass my price series. Sorry, it's price DF. The title, histogram of probable prices days ahead. And that's our prediction period. Okay. And since it's a histogram, this time we'll pass vertical lines, which is AXV. X is equal to my last price. Equal to Y. Line style same as before. I'll just put a label calling it my current price. Now I want to also plot my upper price range and lower price range because it's a histogram as a vertical line. So I will this time define X as PR up range. Color maybe red. Line style. And label should be upper range at person D CI should be putting quotation after days. And I'll pass these two parameters here. And now for the lower range, all right. There's a lot of coding, but it's quite intuitive, and that is the reason we broke down the whole Monte Carlo simulation algorithm into multiple parts. And each part we are dealing with one subset of the entire operation. Okay, let's make our plot neater. Okay. Let's see. There is some error somewhere. Follows keyword. CI and prediction period. Okay. Take above as well. Let's check now. Okay, let's try calling our function. Monte Carlo path 3. Our parameters are price DF, PR up range, PR low range, the prediction period, confidence interval, the last price. Do we have all of these parameters? Yes, we computed all of these parameters from Monte Carlo 2 function when we call the Monte Carlo 2 function, and we assign the output of that function to all of these variables. So let's try to run this here. So what we are expecting to see here are all our simulation results. in a visual manner. Something like what we saw earlier. We are trying to plot various different price paths over different trials. So we should be able to see now a plot of some 10,000 trials over the entire prediction period. So these are our 10,000 trials, and these dashed line represent the confidence interval. So this is the upper confidence interval. Even though visually it may not look very intuitive because these are like 10,000 different price paths, but within this, it represents a 68% probability range. And why 68%? Because there is a 16% probable chance of error on the upper side and 16% chance of error on the lower side. So this represents 68% range of probable prices. And if you just look at the upper range, it represents 84% confidence interval, which means that 84% of the prices are likely to occur below this range, and 84% of the prices are likely to occur above the lower range. And same we can see on the histogram. So this is our current spot price represented by this yellow dash line, vertical line. And we are seeing this as the probable range over the next 10 days. So prices likely to stay somewhere around 18,600 to approximately 19,400 with the 84% confidence interval on the lower and the upper side. All right, so this looks good. Let's